Today's episode is proudly sponsored by the Rising Tide Mastermind. The Rising Tide Mastermind is one of my favorite things that I look forward to each and every week because I get to see people that have my best interest in mind. I know this because I have their best interest in mind. And when you get people together in a room like that, you can just imagine how people want to help other people. If this sounds like something you want to learn more about, go to scalinguph2o.com/mastermind. Welcome to the Scaling Up H2O podcast, the podcast where we scale up on knowledge so we don't scale up our systems. I'm your host, Trace Blackmore. Nation, I love hosting this podcast, and I especially love that you listen to this podcast. And one of my favorite things is to go to conferences where I get to hear things that you want to hear on this podcast. And it just delights me because right now I am in my studio. There is nobody else around. And I am talking to you. I'm hoping I get to talk to you. And the fact that you are listening to me means I succeeded with that. So thank you for allowing this lonely recording to go out to tens of thousands of people that we call the Scaling Up Nation. And of course, if you're listening to this podcast, you are a Scaling Up Nation member. And so many out there are listening for the first time. I met somebody at a conference just a couple of months ago, and they were introduced to me by somebody that said, "Oh my gosh, you're Trace Blackmore. You have a podcast." And of course, I was with my team, and they kind of all rolled my eyes. They're like, "Yeah, we get to see this guy every day. What's your point?" So they were impressed. So thank you. You know who you were. And they took a selfie with me and they said, "Do you know who this guy is?" Again, my team members rolled their eyes and are like, "Yes, we're with this guy each and every day." The other guy said, "This is Trace Blackmore. He started a podcast back in 2017, and he gets me motivated each and every week to try something new, to up my game in industrial water treatment." And this particular person said that they were studying to take their certified water examination because of hearing it on the Scaling Up H2O podcast. So that was pretty cool. I, of course, gave them a Scaling Up button. It was button number 5 for them. And I gave the person that they were with button number 1. So if you were ever at a conference and you see me or one of my team members, again, my team members are going to roll their eyes if you say, "Oh my gosh, you're Trace Blackmore." But they will give you a button after they roll their eyes, and I'm giving them a hard time. I work with some tremendous people. And how awesome is industrial water treatment that we get to work with such fine people? I believe the finest in any industry. And coming together on this podcast, coming together at trade shows like the one I just mentioned. Actually, I didn't mention it. It was the Association of Water Technologies. Coming together with things like that, going to the IWC, which is taking place right now, I believe, we are able to just meet some great people and do some amazing things. So there we go. And if you didn't get a pin from me, make sure, I call them pins. They're not pins, they're buttons. Come on, Trace, you know what you're talking about. So we have so many buttons. I'll tell you a story. We used to buy 1,000 a year, and we started running out mid-year. So I said, "Hey, let's order 2,000." And we actually gave out 2,000 in a year. Okay, well, let's order 3,000. Well, when you buy something like that, you get these breakpoints. Folks, we actually bought 10,000 buttons. And that's a lot of buttons. They take up a lot of space. So you're doing me a favor by taking and giving away those buttons to members of your team. especially to ones that don't know about this podcast. You can say, hey, here is a button, and here's how you find this podcast. And by the way, here is a fun fact about the podcast. Our website gets tremendous downloads from people that listen to the podcast. Now, I talk about going to trade shows all the time, but would you believe that there are trade shows for podcasters? Yes, there are. And I've attended several of those. And when I share our stats with how many people go to our webpage to listen to our podcast, people are just on the floor about that because they're super impressed. People are going to our website. Now, I say all this, maybe I'm going to ruin the whole thing because it's a great thing people are going to our website. We've got so much content there and ways that you can interact with the podcast and with the guest. I don't want you to stop doing that, but I do want you to know that there is an easier way for you to consume the content on the podcast each and every week. And that is a podcast player. There are so many out there. And the cool thing about those is they come to you. You don't have to go to the particular website, download it, and then listen, which is what a lot of people do. And you are welcome to keep doing that. But maybe this is an easier way for you to keep up to date with the podcast. And I'm going to tell you that most people listen on Apple Podcasts. And the second one is probably, well, I don't have the stats in front of me. I probably should have had them in front of me to talk about this. I believe the second one is Spotify. And then we get people that listen to us on Audible. Yes, you can listen to your books and your favorite podcast on Audible. And Nation, let me tell you, if there's a podcast player out there, it's my hope that we are on it because my team specifically makes sure that we are as easy to find as possible on every podcast player. So if you run across one that you don't see us on, let us know that, and we will figure out how to get on that. Now, the cool thing about signing up on a podcast player is you can click subscribe, and as soon as a new episode comes out, it will notify you that there's a new episode there, and it's easy. So don't stop going to the website by any means, but there might be an easier way for you to get content. And I will tell you that when we get people subscribing to this podcast, it actually allows us to get a glimpse into how many people are listening to this podcast. And we use that data to try to tailor next month's shows, next year's shows, what kind of guests we're trying to get on that. So we're just helping each other here, and I'm giving you a little peek behind the scaling up H2O curtain. Nation, I can't remember how many years ago, but I started talking about some of the events that were taking place in the upcoming months, and people in the nation absolutely loved it. So we started doing it each and every episode. So we have a bunch of listeners in the UK. So if you are in Manchester, you might want to go to the European Biosolids and Bioresources Conference taking place November 19th through 20th in Manchester, England. We're going to have all that information for you on our events page, as well as Aquatech China. Aquatech China is put on with a partnership with the International Water Association and the Water Quality Association, and it's taking place December 11th through 13th. So we're going to have all of that information for you as well on our events page. And then January 10th is National Cut Energy Cost Day. And we're going to have a link to this. It's eei.org. And National Cut Your Energy Cost Day encourages all consumers to explore their options and keep up with scheduled maintenance. Each year on January 10th, people are trying to reduce cost in their homes and their businesses. And we, of course, are going to have all that information for you on our events page. And lastly is the 2025 ASHRAE Winter Conference taking place in sunny Orlando, Florida, February 8th through 12th. We're going to have all of that information, everything that I mentioned, things that I didn't mention on scalinguph2o.com/events. Nation, you know I love hosting this podcast, and I know that this podcast means something to people because I am getting people that are asking me to interview other guests. I know somebody that I think would be a great guest on your podcast. Will you please contact them? Or I have information that I think would be great on your podcast. And Nation, let me tell you, back in 2017, I had to explain to people what a podcast was. I had to beg a lot of people to come on the podcast. Of course, now, years later, they are glad that they did. But I know that this podcast is doing great because I don't have to do that anymore. I love it when people reach out to us and say, I have a topic that I think will be great for this podcast. And one of the reasons I think this podcast is so great is I believe that this is the only podcast out there that is not corporately sponsored. Now, we do have sponsored because let's face it, people have to pay for things to get services, and I'm not immune for that. And then, of course, we have a great team that enjoys eating and living indoors. So we, of course, have to pay them a salary. And our fine sponsors help us do that. But most podcasts out there have one sponsor, and people are working for that one sponsor doing that podcast. And there's nothing wrong with that at all. But to my knowledge, we are the only show out there that is totally open to the industrial water treatment community that is not sponsored by one specific product. So, Nation, I just think that's cool because we bootstrapped this from the beginning. And now we've got some sponsors that are helping us out to do all the things that I just mentioned. But because of that, we're moving up in ratings. Because of that, we're expanding our reach to another country almost each and every episode. Because of that, we are finding new listeners. Because of that, the equipment, the programs, the software that we are able to use are better. So, anyway, I just wanted to let you know a little peek behind the curtain today, the Scaling Up H2O curtain. And now we're going to go to our interview. My lab partner today is Ken Robinson of Vista Technologies, a Carita company, Director of Application and Sales for North America. Ken, welcome to the Scaling Up H2O podcast.
Thanks, Trace. Glad to be on board.
So, a Carita company, is that new?
Yes. We were purchased about 5 years ago. And Vista is now 25 years old. Carita is 75 years old. But we were, as you can imagine, very concerned what that merger would look like. And
Sure.
the previous owners to Vista and Carita decided to brand us instead of merge us. So we have the Vista Technologies group, which is what I do, which is going out and fixing membrane process. And then we have the global branding effort, which makes a Vista available anywhere on the planet.
So I do want to ask what your day-to-day looks like.
Well, I've been around quite a number of years, at least 40 years in membrane technology in a variety of different capacities. So I've done R&D work. I've designed and built systems, installed them. I worked for a membrane company at one point in time. I've made hollow fiber, cast flat sheet, not as the prime mover, but as in support. But I joined Avista about 18 years ago, and I was intrigued with their technology and their chemistry. And for 18 years, I've been kind of a glorified troubleshooter. And all of the past experiences, whether they're good or bad, have all come to benefit to this experience because you see everything. And now I have a group that people up to about 18 that run around the country helping end users through a variety of different commercial venues, help them to optimize their membranes, make them work better, which ultimately makes the owners happy because it reduces costs to one degree or another, or makes people comply with various regulatory requirements. But I get the toughest cases now where basically all hell breaks loose. And
They don't throw the easy stuff at you anymore.
yeah, and so we'll form a group from the various disciplines needed and tackle it. And I'm still learning lessons every week because of that.
I'm always fascinated how people get into the niche in water treatment that they are in. How did you fall into membrane technology?
I did fall into it by accident, but when I was in high school, I was very big into marine biology and I wanted to be a marine biologist. Except when I graduated and I looked at the educational landscape, there's hundreds of marine biologists being put out every year, and there's not hundreds of jobs available. So I had graduated early and I took a year off, and my father was in the military and he ended up moving to Cornwall, Ontario to be an instructor for air traffic control. And my mother sent me the local college calendar, and I was flipping through it. One of the pages said marine engineering technology. And I didn't know that was even a subject. But as soon as I saw it, I called them up and I said, I know what I want to do. And so I went into this specialty program. There's only two colleges at the time in the country that were teaching it. And this was a new program within this college, but it included internships every summer. So I went to sea for 3 summers. And on the last summer, I was on a hydrographic survey vessel out of Dartmouth, Nova Scotia, and spending most of my time in the North Atlantic. But the ship had just installed one of the very first desalination ROs. It was its maiden voyage, and nobody knew how it worked. All we knew that it made good water from seawater. So when you looked at the system, it looked like it was built around a light industrial commercial standard. And they bolted this thing between two large cat generators. And basically it shook itself apart about once a week. And so you'd be working in the engine room house and you hear a big pop. And then you'd see a stream of water shooting across the engine room, 20, 30 feet. And so we're always just putting this thing back together again. And so when I graduated college, I decided not to pursue that as a career line. I was looking for work and I walked into a startup company in Ottawa, Canada. It was called Memtech Corporation. And just because I had seen an RO system, they hired me on the spot. I started in the shop and I helped to build the systems. We specialized in maple sap concentration at the time. That was the moneymaker. And so I did install, service, startup, built these systems for quite a while. And that's how I got into it.
So, obviously, today's topic is about RO, specifically high recovery RO. So, before we get there, do you mind taking the Scaling Up Nation through the RO process?
Yeah, sure. Today's RO systems, most of them are using what they call a thin film composite membrane. Those are basically broken into three categories. There's like a seawater style, brackish, and a low energy. And then there's an offshoot called nanofiltration, which it's characterized as a loose RO. But if you think about it, the RO membrane as a general class is just a rejection machine. However, it's designed, it just rejects dissolved minerals at a certain percentage. And along with that, you'll be able to reject other things like macroorganics and things like that. But it's just a percentage rejection. So if you have 1,000 ppm coming in, on average, 99% of those minerals will get concentrated up and discharged, and the pure water side will have the remaining 1%, and that's what everybody's using, whether it's boiler feed or putting water in a bottle or continuing the process and making it into pharmaceutical grade, whatever. That's how I would characterize that.
So I'm in Atlanta, so there's a fairly large beverage manufacturer here, and where they make their bottled water, of course, they're using RO, and then you read the ingredients and it says minerals added. So they're taking them out to put them back in.
We're funny species because we prefer things that taste good. And so there's a science of remineralization of basically a distilled high purity water so that it tastes good. So yeah, everybody's doing that.
So what makes an RO system high recovery?
Well, the technology, it took off, 40 years ago. Like when I first started, I caught the wave. Nobody knew what it was. And when we built the first systems, we were limited by what the anti-scalant could do. And most of the first systems built, the anti-scalants were limited in the Langley or saturation index that could be produced in the concentrate to about 1.5. And depending on the product, that might vary a little bit. And so everybody had to inject acid ahead of the ROs as pretreatment to lower the pH, add the anti-scalant. And so even with that, the recovery limitations were dictated by the chemistries to a certain extent. And so you would get anywhere from 70 to 80%, and life was good. And nobody was really looking at it much beyond that either. As the anti-scalant technologies improved, like at Avista now, we have a lot of performance chemistries that can easily get your LSIs up into the 3 range. That allows you then to design systems that are high recovery. The problem is that if you have a pre-existing system, conventional RO, the array of vessels and membranes in that system is designed such that for a certain hydraulic profile, and you just can't go in and make it do something different. The new industry of high recovery started, and this is where you would take the concentrate from a conventional RO and then you would send it through a recovery RO. And so that RO would have different design considerations, usually higher pressure, a different hydraulic profile and a different recovery profile. But that's where high recovery was truly born, was to improve the efficiency or reduce the wastage from the conventional processes.
What industries would we see high recovery on?
Well, in the early days, primarily it went to industrial applications, but now everybody's using high recovery, municipal, food and beverage, power, everywhere where there's either a regulatory concern or issue or whether there's an economic benefit in recovering and not wasting the water you're taking into the plant and then not having to get charged for it on the wastewater end.
Can you give us an example where regulatory was a concern and a high recovery unit has helped that customer?
Well, in general, like the beverage industry, particularly like bigger companies like, Pepsi and Coke, they have over the past few years have really looked at their cost of operations and where they can regain sustainability because that's a popular topic and lower their operating costs. So high recovery is huge in the beverage industry. It's also, but that's like they're kind of driving that because they know the regulations are coming. We have a customer in Colorado, it's a power plant that the regulatory requirements are forcing the plant to have a 97% recovery on membrane process. And so they installed all the necessary equipment, pre-treatment, everything to try to get there. Unfortunately, the water quality changed from the time of bidding to startup, so they're not quite hitting the mark, which is forcing an ongoing like what do we do now kind of process. But that's a good example of regulatory driving the technology.
You hit on this briefly, but can you go in more detail some of the issues we need to be concerned, some of the limiting factors when it comes to operating one of these systems?
Some of the factors, are just universal. When you go into high recovery, especially with the newer systems, what we call the dynamic RO class, which would include, companies like ID and Rotec and Decelitec, which is now a DuPont company, you really have to have your feed water quality parameters strictly defined and then know what the variability of those are. The slightest movement on like an aluminum, like zero point 0.1 ppm of aluminum can be too much in some of these applications. And so if you don't model that early phases of the project and you have to find that out at startup, really gets a lot of people angry.
I can imagine.
So water quality and variability are huge. And then with the dynamic RO, because you're playing around with the inhibition timing of the anti-scalant and you're pushing it to its maximum limits just from an equipment design, process design, the overall project, water's going to do things you didn't expect it to do necessarily. And so you have to have some flexibility in trying to catch these things and then make adjustments on the fly.
I don't think anybody buys equipment because they want to buy the equipment. They buy it because there's going to be a return on that investment. How do you prove that return on investment when you're talking with a customer?
Well, most companies, including us, have, calculation methods. We call ours CSV, customer shared value, or creating shared value, I think it is actually. But you can put in a set of conditions, current conditions in any plant, and then you can hypothetically model changes in the process, in the recovery, and look at water savings, wastewater savings, energy savings, can change pre-treatment and get membrane life savings. All of these things can be easily calculated for your return on investment now.
So you've surveyed, you've asked good questions, you've received what you hope to be as good data. The customer bought into that. They see the benefit of getting it. Now you're starting it up. How do you prove that it's working? How do you make sure that it's working? And what are some of the things that you need to take close attention to?
Even in the early days when people were taking on the standard high recovery processes, there always seems to be a disconnect from the applications and the salespeople that are developing the idea, selling it, and then it starts up, and operators get overwhelmed, and they train them, and they say, "Give us a call if you have any problems," but there's a huge training disconnect between the beginning and the end point. And so many times when we started to see these high recovery processes initially show up, when we walked in the door, they were all the same. They were all turned off and the membranes are all scaled up. And so a lot of the misunderstandings that create these situations is because people don't really understand the behavior of water as you concentrate it up and move it around. And in a lot of these particular plants, it's the brake tank that's between the primary RO and the recovery RO that was creating a lot of the problems. And the reason that it was creating the problems is because nobody really understands what's the anti-scalant doing when it leaves the first RO and it sits in a tank and then goes into another RO. And so there's particular design changes that you can make to the brake tank that will make the recovery RO run much better as you concentrate up these feed waters and you get into these high recovery processes, moving from these conventional recovery now to the dynamic. Well, like say, all of this gets just that much more sensitive. And so when you're teaching the operations what to do, much easier before dynamic RO showed up, because all you would have to do is define the maximum operating limits of the reject of the recovery RO. You would literally say, and you would have to do more analytical work, but you would actually put a conductivity and a hardness and a whatever limit, do not exceed this value. And so you can be standing in this room filled with equipment. The operator can go and tweak something, and to give them a comfort level, was that a good tweak or a bad tweak? Let the system settle in and then go to the concentrate, measure your key variables. Are they within the limits? That little training dynamic saves a lot of operations. When you're looking at the dynamic RO, they're very complex processes compared to a conventional RO or a recovery RO. in that everything's moving. That's why they call it dynamic. And so you walk up to a machine that's running in one of these cycles, you have absolutely no clue if it's doing well or not doing well. The trick, if I could say it's a trick, it's your best shot at figuring out if these things are running or not is to capture, snapshot all the data at the very end of each cycle and capture that data and then normalize that data. And that will give you much better clue as to how things are going. But it's an order of magnitude higher in training that you need for the operations to understand, looking at all these trend graphs and all this data. Like, it's overwhelming. But catching the end of the cycle is a huge way of overcoming that, just to see if you're doing well or not.
I'm curious, with your years of experience, what's the proper response when you're talking to an operator on the front end? You've done the training, you've done all this stuff. Call us if there's any issues. And then you go back to do some service and they've turned the unit off because it's scaled up. What's the proper response to that?
Well, I've been personally blessed working at Avista in that every time that call has come in, it's like, hey, we have our RO system is scaling and we're using your anti scalant. The first thing that enters my mind is that, well, that's an impossible word combination. And so you start an analytical program and a troubleshooting set of analytics to see what happened. And I can guarantee you every time something else happens. And so it's what we call the aha moment. There's been some projects went on where it's taken us like 3 months to find the aha moment, and you're working at it all the time. And it usually comes when doing something like this. We get everybody on a Teams call, could be in person, in a boardroom, or everybody that's involved. And then you look at all the analytical data, because the analytical data is a symptom generator. And water is very predictable in how it behaves. It doesn't do anything mysterious. And so you get everybody in the room and you go like, what's the series of combinations, all the possibilities that would create that symptom? The triggers for the symptoms could come from operations, it could come from the way the process is set up, or it could come from how the plant is physically designed. And so you have to go through all of these different topics. A lot of the aha moments come with operations, actually. Some operator will say something and you go like, "Wait a minute, what do you do when that happens?" And it'll be that. And then usually it's, "Well, that's the way I was trained to do it." And they just didn't know. There's a few circumstances where like technology has exploded so quickly into the global marketplace. There's so many companies building ROs, but there's a lot of people that still don't know how to design an RO system. And because depending on the market you're in, there's so much competitive angles being offered that all the good features are being stripped out of systems. And so there's a segment of fixes that involve retrofitting the RO. Like, this is not going to ever work for you because they did it wrong. So we help make recommendations on what all your options are to fix the process, whether it's operations, process, or design.
When it comes to membranes, are these the same membranes we're using in regular ROs? Are they different?
For the most part, yeah, everybody's membranes will fit everywhere. The nuances come more with the feed water source, because if you're dealing with surface water and you're going through all the seasons, and then depending on the nature of the pretreatment, that will generate certain fouling characteristics. And so you can select membranes with different feed channel spacers. There's actually some newer feed channel spacer designs that help to reduce the pressure drop through an element in these high particulate loaded waters. So there's more being done with optimizing the engineering around the element as opposed to picking a certain brand of membrane. So there's more work being done there, I think.
You've spoken a lot about fouling membranes. So when that happens, what is that cleaning process like and how often should that be done?
Well, my record holder is, we had this customer in middle of Illinois. I actually bid on the system 30 years ago and lost. The equipment manufacturer put in a conventional iron manganese removal system with aeration, chloration, detention, filtration, and then with a stripped down RO on the back end. That plant ran for 15 or so years, cleaning every quarter, 2.5 year membrane life. We were building plants around them differently and getting much better success. And then when I moved into Vista, we are able to bring this customer on as a customer. And we started talking to them like, this, like your plant really sucks. So we partnered up with the city's engineering firm and then good OEM that had a field retrofit capability. There was some government money available, but we gutted the plant and changed it from a conventional pretreatment to an anaerobic where the silt density index numbers coming off the wells are very low. So we took everything out and put a new RO design in, but that plant runs with a 7-year cleaning cycle, and the membranes are currently about 11, 12 years old. We don't know where the end point is. So pretreatment is king in dictating the frequency. General rule of thumb is surface water applications are always going to clean more frequently than the well waters, depending on the pretreatment again. And then how far you're pushing the process will also, dictate that frequency.
What are some things you're looking for to make sure that cleaning was successful?
If you want to get maximum membrane life, then the plant should be collecting the necessary data to normalize the process. And you should make sure that happens just before cleaning. And then once you've gone through the cleaning process, whatever it is, when the plant starts up again, you take all the numbers and then you see, did I return the base numbers to the original startup values? Yes or no? If the answer is no, then you didn't get a good cleaning. If it's yes, then you did. And so what happens to the plants that answer no, if they're doing that, is that each time they clean, they will lose a little bit of the net driving pressure advantage they had. And you'll just see over time that the net driving pressure just keeps building and building and building, or the differential pressure keeps building and building just a little bit each time. And then they get to a point where they have to do something because they just can't make the quality or the quantity. And they just, sometimes it's not too late and you can implement a decent cleaning program and recover, but that's how you would kind of distinguish that.
What would you say some of the technology advancements you've seen over your career have been?
In equipment or chemistry?
You can select from either category.
That's a tough one. Well, when I started building systems back in the 80s, I had the luxury of no competition. I was working in Minnesota at the time, and I linked my success to Film Tech Corporation, which was just Film Tech at the time, which made decent membranes. We went about and built the very first municipal power, everything ROs in the upper Midwest, all the upper Midwest states. And so I could design the system how I wanted it, how the film tech people thought it should be designed. And so a lot of those design principles are still good today. And the ones that vary and don't pay attention to those will struggle, especially if they get into, a feed water that's challenging. And so from the equipment side, low energy membranes came, which was an innovation. And then nanofiltration membranes came. That was another innovation. So it just allows you to play around with different types of process. And now with the dynamic ROs, that's probably the biggest, innovation moving forward because now you're pushing process to a limit that's never been done before. The chemistries had to keep up with that over time, but back when I built my first municipal RO system, there was only one anti-scalant manufacturer, and their anti-scalant was just dreadful. But the very first startup I had, I was using this particular formulation, and I had piloted with it in an anaerobic pretreatment setup for several months, which is where you keep your iron and manganese, all the metals in solution. When I started the plant up, went into bid and became a full scale plant, the engineer put in manganese green sand as pretreatment to the RO. And so when the plant started up, the manganese green sand filter worked perfectly fine, but it produced a really, really low ferric iron particulate. Again, nothing wrong, but it was there. And that anti-scalant combined with that little particulate, and it just killed the flux on the RO right at startup. And in trying to figure out, I thought it was a career ender, but in trying to figure out how to recover from this, I was working with Film Tech and they said, hey, there's this new company started up in California. It's called Argo Scientific. Why don't you give them a call? And so I did. I ended up talking to an individual, Dan Comstock, who is now considered the father of specialty chemistry formulations. And I told him what my problem was, what I was using, and he goes, "Yeah, I know what your problem is." And he sent me a drum of anti-scan. He said, "Use this." And so I put on 3 ppm dose on this project, and not only did it stop the fouling, it actually reversed the fouling as it ran. And over a 2 week period of time, it returned all my values to startup condition. And I was just like blown away that 3 ppm of a great chemistry could save your career. Fun fact, Dan Comstock was one of the three owners that started Avista. So there's Karen Lindsay and Dave Walker. They're the ones that took the Argo Scientific experience and moved it into Avista. And Dan continued to develop great chemistries and analytical techniques and hang on for the ride, so to speak. But yeah, so those are the kind of innovations that have happened. I think those are the key ones.
What are some of the new innovations you think are yet to be had? Where is technology going in the future?
I think on the chemistry side, I get to see global R&D effort that companies like Carita are looking at, but there's new polymer chemistry that has been developed that's going to continue to allow processes to be pushed even further. We have new products that come out every year. That's an ongoing thing. So you're either going to be able to clean more efficient and or extend saturation limits of specific scales farther than they can now. So that's an ongoing process. The nuances of dynamic RO, despite what everybody's saying, nobody really knows all of the variables on dynamic RO and how they play out on a specific feed water quality. So we're dedicating quite a bit of resources to figuring that out because you have plants that work fantastic and you got a bunch of plants that work okay, and then you have disaster plants. So, like, what's the difference? So that's being flushed out. I was recently watching a presentation by, if I can mention the company's name as an example, Fedco out of Michigan has developed a high recovery 1800 psi operating system with energy recovery devices, and they're playing around with dynamic RO. And so the osmotic limitations of high recovery are being pushed by companies like that and others because the 1800 psi element is readily available through multiple manufacturers now. And so how that is going to take and be used even in, like, I was listening to a Pulse RO podcast, and even they're looking at the 1800 psi elements and how that's going to impact their processes. So you'll see some things like that, I think, especially since zero liquid discharge or minimum liquid discharge again is a big topic. So any efficiency gain that you can do, everybody's looking at that, and there's even some new membranes out that are focused on reducing the fouling characteristics of traditional membranes. So you're going to see all sorts of innovation coming, I think.
What is pulse flow technology?
That's the IDE dynamic RO. IDE has pulse flow, and this is one way to play around with anti-scalant inhibition timing. So for those that are maybe not familiar with that, this is why everybody gets into trouble. But when conventional ROs were designed, and then the modeling that came with it for anti-scalants, the general industry standard was that the inhibition timing of an anti-scalant, this is the inhibition timing is the delayed response of the supersaturated solution from producing scale. So anti-scalant doesn't change the saturation limit of a feed water, it just delays it. So that was 24 hours in process. When dynamic RO came along, what they're doing is they study pretty intensely the inhibition timing, the actual inhibition timing, and They discovered that as you concentrate up a given feed water, if you can then move it or get rid of it or do something with it before it exceeds the inhibition timing, you can actually pull more water out of it than you traditionally could. So pulse RO is a dead end process where the concentrate valve is closed. They're applying pressure to a membrane and it's concentrating up very quickly. It's only 20 seconds. And then for several seconds, they open up a brine valve and they just blow everything out as quickly as they can and then reset the cycle. And so there's never a time where that concentrate stays in process more than 20 seconds, give or take. And so by doing that, they're playing around with, like, say, that whole new discipline of figuring out, well, like, what actually happens as you concentrate up feed water. Rotec does it with flow reversal. They change directions, move blocks around. Decelitec does it by doing a continuous batch process. So they bring up in a big recirculation loop, they'll bring up a feed water to an endpoint and then flush. It's all involving, similar types of movement, but all playing around with inhibition timing.
Ken, how does concentrate management become more complex at high recovery rates?
This is actually a very interesting topic even before high recovery became a thing, but if you worked in the middle of the continent, you're always dealing with very hard water, high alkalinity. Even the conventional ROs for the most part have operating in normal recovery rates, 75, 80, 85% would bump up against the limit for that particular scale. The modeling, everything you do with an RO, the assumptions you make, even in piloting, everything is in process. Once the concentrate leaves the RO system, and this is why I mentioned earlier the break tank between the primary and the recovery ROs are problematic. On a conventional RO, there's many engineers accidentally discover too late that you can't bury 2 miles of concentrate pipe to the outfall. Once the concentrate leaves the RO, and even in dynamic RO processes, we're actually already working with several plants on this particular topic. The inhibition timing becomes an unknown because you've exposed it from a controlled process to other variables. You're aerating it, it's splashing around, it's sitting in tanks, it's being pumped. And so those have caused some really big problems because the scale starts coming out of solution well in advance of when they really wanted it to. We've had a pretty decent history in the middle of the continent helping all the conventional plants figure out how to get around the problems if they inherited them. It's just nice to see that a lot of those lessons learned we are actually reapplying into the dynamic RO. The two rules of thumb to make life easy is always get your concentrate, regardless of the system, to a dilution source as soon as possible. And when the RO shuts down, make sure you get 100% drainage with no dead legs, no standing water anywhere in the concentrate system. Have 100% drainage. If you do those two things, you'll have a much better chance at having a successful project.
Ken, if you could concentrate this conversation, see what I did there, and you could only get one point across, what would you want that point to be?
Having been involved with process for so many years, I've worked in a variety of different companies and seen process from a variety of different perspectives. It only takes once to be involved with bad process and get burned by it to realize that you don't want to do it again. I'm very particular on, and we use these skills in optimizing membrane process, but I'm very particular in what I like to see ahead of a project, especially, and piloting may or may not be helpful because that's a different topic, but it's interesting how even a successful pilot, when you scale it up, will create new variables of process issues like the concentrate. You want to be very particular on making sure you've collected all the correct information, have characterized your feed water quality and variability, but not only from the ionic standpoint, but from the particulate standpoint and the metal standpoint. You just demand those things, you will have a much lower risk of having an issues, but you'll have a much higher risk of success. And if you don't get those things, just call us because we'll tell you what you did wrong and how to fix it.
Ken, if somebody just tuned into this episode and they just learned the term high recovery and they want to start learning more, what suggestions do you have for them?
There's a lot of great videos on YouTube.
What did we do before YouTube?
I know. Even if I'm trying to fix something around the house, I'll just Google it. I actually picked a lock. I picked a safe for my neighbor by watching YouTube videos. But
I'm hoping that this recording is not used against you someday. So we might edit that out just for your safety.
yeah, you can go to all the major platforms like ID, Rotec, Decelotech, and there's a lot of great podcasts and pre-recorded information that will tell you how they view it. And then there's other resources if you just scan specifically. If you're actually going to consider purchasing a high recovery, depending on what style it is, I would recommend that you talk to people that are doing it and find out. There's a wealth of information when you talk to the operations group of any company. Did this work for you? Did it not work for you? What were your lessons learned? That was one of my training events early in my career when I was in Minnesota and we had this relationship with Film Tech. We said that we want to build municipal RO systems. Can you help us? And they sent myself and a couple other people from our company down to Florida. We hung out with one of their top process people who's now retired, but we just toured plants for a week. And that was back in the hollow fiber days, the DuPont hollow fiber systems for the most part. But boy, you just got a wealth of information talking to operators like, hey, if you could redesign this plant, what would you do? That's what I would recommend.
Ken, we'll make sure to have your contact information on our show notes page. So if anybody wants to reach out and get some further information, but I do like to ask lightning round questions to all of my guests. Are you buckled up? Are you ready?
Fire away.
Ken, first question. If you could go back in time and talk to your former self on your first day as a water treatment professional, what advice would you give yourself?
That's an interesting question. When you look back at yourself in your 20s, I think a lot of people are in this because you're young and you're wired for everything. I think you make the mistake of thinking that what you know is how you're going to be identified with in the industry and that that's good enough. I mean, I was fortunate enough to learn and have a lot of great coincidences. I mean, when I worked at Memtech, we had a joint venture at National Research Council and they had a membrane division and Dr. Suri Rajan was there. I got to hang out with Dr. Suri Rajan, who's, he's the founder of flat sheet spiral membranes. And didn't he know he's there? So you can pick up a lot of knowledge, but as you advance in your career, especially if you're changing jobs and taking opportunities, your boss might have hired you for a specific reason, but not everybody else is happy to see you. Developing the skills of leadership and especially servant leadership is probably a good topic to wrestle with early in your career, in addition to the technical knowledge.
Great advice. What are the last few books that you've read?
I'm a big reader, nonfiction. One of the recent books that I really enjoyed was Diary of a CEO, 33 Lessons in Business and Life. Stephen Bartlett. He's got an interesting backstory if you can pick it up, but he also has a podcast by the same name. It's called Diary of a CEO. So you look, got quite a few podcast guests, probably one of the more popular ones, but he has phenomenal people involved with all aspects of business and life on there. I highly recommend that book and that podcast. Another book is great, Think Again by Adam Grant. It's Power of Knowing What You Don't Know. Adam Grant also has a podcast called Work Life with Adam Grant. Again, amazing guest speakers, but his podcast is dedicated to making work suck less.
I love it.
That's his words. And then lastly, especially when you get up into my portion of the career where you get some gray hairs and age behind you, there's a great book called Lifespan with David Sinclair, Why We Age and Why We Don't Have to. It brings you up to speed on the science of aging and what you can do about it, what you can't do about it. But he also has a podcast similarly titled. So
I love we get podcast recommendations as well. Ken, when Hollywood hears this episode, no doubt they're going to create a script about your life. Who do you want playing Ken?
Wow, that's a hard question. The first person I think that could play me and maybe characterize my attitudes and demeanor would be Michael Palin. He's one of the characters from the Monty Python troupe. Of course, they were the groundbreakers in bringing absurdist comedy into the marketplace. But in later years, he's actually become a great documentarian. If you check out his work on PBS, but he's traveled all over the world looking at different cultures and different places. He's really a great documentarian, and he always brings his subtle Monty Python humor into the works. So I would think that would be a good fit for my life role.
Love that answer. Last question. You now have the ability to speak with anybody throughout history. Who would it be with and why?
I would have to say this will go full circle, back to the beginning of the podcast. I wanted to be a marine biologist. So Jacques Cousteau, for those who don't know him, he's passed, but him and his Calypso, they had a TV show and they go around the world looking at marine biology and what's working, what's not working. But the last summer that I was working on my internship, I was on that hydrographic survey vessel, had the very first seawater RO. We were in port for a week during that summer, and the Calypso pulled up right next to us. It was at the Bedford Institute of Oceanography, and they were having a big environmental conference, and the Calypso pulled up. But I couldn't get anywhere near Jacques Cousteau, even though I walked near, but he was just surrounded by so many people. But for 3 nights, we got to hang out with the crew.
Wow.
Yeah. And so obviously, night one, my first question was, how do I get a job on the Calypso? Because I was ready to stop what I was doing and just transfer ships, But unfortunately, it was a 3-year waiting list, and I probably needed a lot more degrees attached to my name, I think, to get on board. But anyway, Jacques Cousteau would be the man.
Ken, a follow-up question. Are you a scuba diver?
I am.
I am as well. We're going to plan a trip after this podcast.
Okay. Awesome.
Ken, I want to thank you for coming on the Scaling Up H2O podcast, sharing so much about what you do each and every day. And we'll make sure to put all your contact information in the show notes page so people can contact you if they have some more questions.
Very good. Appreciate it. I enjoyed this.
Nation, I was so excited to bring you the interview. I forgot to tie up something I mentioned in the previous intro, and that was this was a guest that was recommended by a listener to come on the Scaling Up H2O program. So thank you, listener, for putting us in touch with Ken. And I think that is just tremendous because, Nation, we're going to hit 400 episodes on our very last episode of the year this year, which means we've got to find content for 400 more. I love doing this podcast. Hopefully, you love listening to this podcast. So we need to make sure that we have the next guest. We need to make sure that we have the next topic. So if you have an idea, you can go to scalinguph2o.com, go over to our ideas page. Let us know what that is. And maybe, just like Ken, we'll be able to introduce ourselves and get you on the Scaling Up H2O podcast. Somebody that I already knew before this podcast. In fact, this is somebody that I called when I was thinking about doing this podcast. And I was about halfway through explaining what the idea was. And he said, you got to do it. Stop talking to me. Start doing this. This is going to be tremendous for the water treatment industry. Of course, that's our friend James McDonald. And he has just been fantastic with helping us with weekly content, with motivating you to think about something a little bit differently. Maybe you're going to do something a little bit differently. But one thing's for sure, he is raising the bar in the industrial water treatment industry, and that is the whole point of the Scaling Up H2O podcast. Here's James.
Welcome to Drop by Drop with James, the podcast segment where we wonder, explore, think about, imagine, and learn industrial water treatment, you guessed it, drop by drop. Together. Today's episode is a what if. What if a cooling tower blowdown valve loses power? Will it fail closed or fail open? What could be the impact if it failed closed? What would be the impact if it failed open? What if the entire cooling system power failed? How would this be different than just the blowdown valve losing power? Is knowing whether a valve is designed to fail open or closed important when replacing a blowdown valve? Can you tell by looking at a valve whether it will fail open or closed? I'm James McDonald, and I want to encourage you to be like water by forming bonds with those around you, dissolving new knowledge, and making worthy ripples, drop by drop.
Thank you, James, and thank you, Scaling Up Nation. So many people hear about this podcast because of people like yourself letting others know that we have an industrial water treatment podcast out there with so much content to consume. And it's not just my voice. Folks, if you go on our website, there is so much content on our website. After doing this since 2017, whenever I Google something about water treatment, it is very often that the Scaling Up H2O podcast are the first 1, 2, 3, 4, or 5 entries that come back about that topic. There's just so much up there. And our team has made it so easy for you to search. If you're looking for a particular topic, you can go to scalinguph2o.com, type in what your topic is, and it will pop up all these different resources that are within scalinguph2o.com and make your learning that much easier. Not to mention all of the resource pages we have. We have several resource pages on content-specific topics that make it so easy for you to narrow down, to learn more, to do the next thing, to share with your customer, whatever it is that you want to do. We're trying to make that easy for you, and we're doing that one episode at a time. Thank you for listening today, and we'll have a brand new episode for you next Friday of Scaling Up H2O. Struggling to prepare for the Certified Water Technologist exam? Our Certified Water Technologist prep course is here to help. Gain the confidence you need with comprehensive study materials and a 100-question practice exam. And the best part, we offer a free version to get you started. Head over to scalinguph2o.com/CWT prep and take the first step towards your certification today.